audio, but if you're ever absent, you can look for a link in Schoology. You can get the notes from a video in Schoology. Okay. The problem is I need to get like a little microphone or something because when I walk away, they can't hear me talking. So people say, well, miss, I can't hear your video, but the video is really so you can at least get the notes and see the visual of what we did. Okay. So when you're absent, you actually have to get the bell work. Because the bell work story is so important. So if you're absent and you go into Schoology and you click the video link, you can see the bell work. It'll show the date, it'll show the assignment, and the bell work. So the videos are really helpful that way. Okay. All right. So did everybody write the assignment? Homework? Should have wrote same page as yesterday, but it's 7 through 13. Here's our standard. Don't do it right now. Here's our standard. MA stands for mathematics. What do you think 912 stands for? 9th through 12th grade. This is the high school standard. Like the 8th grade standards would say 6 through 8 or something like that. So this is specifically for high school. What do you think the F might stand for? It's a vocabulary word, a math vocabulary word, F. Function. So could be fractions, I don't know. So it's mathematics, 9 through 12, functions, 2.2. Right now in Algebra 1, our standard is exactly the same, but it says 1.1. And it's like solving equations. So anyway, you should know that the state mandates everything we do, and then they note it with these little codes. So your language arts class doesn't start with MA, your history class doesn't start with MA. This is specifically a math standard. So you today are going to work on figuring out the effect of the graph of a function with 2 or more transformations by adding a number to the x or y value. We're actually going to sit here for now. Okay, it then says to pick any parent function to draw and then translate it down 5 units. So I actually am going to take volunteers to come to the board for extra credit. This will go in focus in the accountability column. So this will be our linear function. It doesn't have to be perfect or beautiful. You can see I'm not trying to make my lines perfect here. I'm just getting this up here. So just come up and do it. Draw the parent linear function on the handout and then move it down 5 units. We also did what absolute value. I'll do your little x and y axis again. Not looking for perfection, just participation. And then the last one, I should do the constant again. Here's your quadratic. You don't have to do all 4, you guys. You're just doing 1 on paper. I'm just going to call people up to the board so we see all 4. I reviewed them yesterday. On paper, you're just doing 1. Okay, so when you volunteer, you get to pick 1 person to come with you. And both of you will get extra credit regardless of if it's right or not. So can I get a volunteer to the linear parent, move it down 5? Elijah, and you can bring someone with you. Absolute value. What's your name again? Daniela, you can bring somebody with you. And I'm going to pause the video. Up top. It should say algebra 2. It should be kind of purple. You need to tear out the whole first chapter so it's through page 100. Actually, you guys, why don't you get your books, sit down with it, and we'll figure it out at the end of class. There's a little bit of. So this is page 13. I'm gonna come around and give you credit for doing it. So did you remember to do this after school? All right, so number one, I think I did with you for the most part. Number two, it's a U shape. You call it quadratic. Um, Now on the handout, the arrows point up. Anytime the quadratic is pointing down, you say there's a reflection. It's a reflection across the x-axis. It's been flipped over. Now this yellow one that I drew is if it was just a reflection. It would be a perfect flip. So the parent function is right at the middle origin. If it was just flipped, it would look like this. So it's been flipped and then it's been moved up 3. So it's a reflection up 3 units and it's actually a little bit skinny. The way I know it's skinny is that the parent parabola starts in the vertex and the very next point is over up 1 and down 1. Over 1, up 1, or over 1, down 1. And this is over 1, down 2. So that's how I know it's skinny. So the more comfortable you get with that, supposed to being the first point, the more you start to see the skinny wide bit. All right, the linear graph was the most misleading. The axis was misleading. Did you guys catch this? The y-axis is going by 5s, and the x-axis is going by 1. So when I looked at this, I thought, oh, what is that, like 0.4 or something? You know, I wasn't quite sure. And then first I know how to read the equation correctly, but then I realized these are 5s. So this is actually down 2. And then it's difficult to see, but I know the slope is 5. And the parent function slope is 1. So it's actually a vertical stretch, but you can't see it. It's a vertical stretch of 5. It's skinny, but you can't really tell. And then that constant is up 2. Who's got a question on those 2? All right, and your word problems, all you had to do was try to say which function family it belonged to. So how did I know that the word problem about the pebble, is it a pebble? The beanbag. How did I know the beanbag belonged in the quadratic function family? Because the variable t is squared. T stands for time. It could be x. It could be anything. If the variable is squared, if there's a power of 2, call it quadratic. Okay? In this one, the vehicle is purchased for $10,000, which is really difficult now to find a car for that much. And it's going down $1,200 every year. It's not worth as much. Since x, it doesn't have any bars, and it's not squared. It's just a plain old regular x, you call it linear. Okay? All right. Yep. Okay, so here's some vocabulary that you have to know. You have a quiz next Thursday. There won't be vocab on it, but on your chapter don't make you write out definitions. You have to write enough math. But you have to match definitions correctly. So what I want you to do is find these words in the book. If you want to write the definitions, you go for it. If I were you, I would write the definitions. But I write very quickly, and I like writing things. That's why I'm a teacher. I'm still in school, right? I recognize that not everybody likes to write that much. Take your book, and if you don't want to write these definitions, highlight them. Underline them. Maybe you love Post-its and organization stuff, and you have some nice little Post-its that your grandma gave you for school, and you want to Post-it it. That's cool too. Whatever you want to know, whatever you want to do to know these words, you do it right now. Yeah, I got the page number here for you. Read it, let it sink in, and maybe you say to yourself, I know this word, I'm not writing it down, that's a waste of my hand effort, and you move on. Okay, maybe you say to yourself, there's no way I'm ever going to remember this, I better write it down. That's up to you. This is your chance to get to know your vocabulary. Now, in a minute, I'm going to put a slide up with a lot of stuff that you do have to write. So you know there are some required notes in a minute. So just read these and get comfortable with them. If you do write it down right, you can shake your hand because I'm going to give you some things that are a little different. Go ahead. All right, another minute or two, and then I'm going to move on. And we're going to actually use these words. Oh, I know, I walked around and vocabulary, reflection. So let's move on. Move on. All right, here's the observations that you want to upgrade your understanding about these function families with today. So when you look at the parent function, it's just f and maybe an operation. Equations can get so much more complicated when you add other numbers like coefficients and constants. So this is the parent linear function. If there is a number in front, a coefficient, what that number will do, we call it a. If a is there and it's negative, then there is a reflection present in the graph. If a is greater than 1, then there's a stretch. The slope is tall and skinny. If a is less than 1, then there's a shrink. It's actually a flatter line. Okay? So in our equations, if there's a number in front, we all refer to it, all the mathematicians, we call that value a, and we know exactly the effect it has on our graph. It has the effect of flipping it if it's negative, has the effect of stretching it and making it skinny if it's greater than 1, and it has the effect of making it wider if it's less than 1. Okay? Now, if our parent function equation gets more complicated and all of a sudden has parentheses in it, or there's a number in the brackets, that value is called h. I'm going to zoom out a little more. I know it's getting pretty small. Sorry about it. A number present here in parentheses or here in the brackets or in a quadratic in parentheses, that's going to do a horizontal translation of the graph. That's going to move a graph left or right. And the weird thing about the h value is it's going to move opposite of how it looks. And when you see that in a picture, that's going to make more sense to you. Now, there's one other value that's going to show up in our equations. It's a number at the end, and we call that one k. K is the easiest one. You guys already showed an understanding of k when I wrote these equations on the board. K is a shift up or down, and it's a number at the end of the equation. So in Bellwork, when I said, oh, well, this equation is just x minus 5, and this one is absolute value x minus 5, and this one is x squared minus 5. The minus 5 in each of these is called k, because it moves the graph down 5. Okay? So, your task today is to see an equation and be able to tell me, does that number represent A, H, or K? Elijah, you want me to? No, I would do like 4. All right, when you're ready, you're going to try seeing how this is all applied. You go to page 9 when you're ready and look at the gray box and try these questions and try to figure out what this is all about. And you guys who are tearing pages out, put the book back on the bookshelf when you're done tearing pages out. You don't keep it. I mean, are we ready for page 9 now? Yeah. The only thing I ask, are you ready? Is that you go into your gallery and you create an album for math pictures. Okay. Because people take pictures and lose them. But if you want to use that device and have your pictures in order in a chronological order in a nice math gallery, that's effective. But taking pictures and then scrolling through it and looking at it in class, not as much. I'll go back to this at the end, okay? So put your phone away right now. All right, so here's our 3 equations that says graph the parent function and this one. So anytime it says to graph the parent function, you use the handout from yesterday. All right, all of the parent functions are on the handout from yesterday. So you say, okay, what function family is this? Number 3 is linear. The handout from yesterday, it goes through the origin, and it has a slope of 1. There's the parent function. The goal is in the next few days just to have the parent functions memorized, so you can put them down easy. And if you just do the problems, you will. You practice them all. So now you look at this plus 3, and you think, based on the models we were looking at, do you think that's in the A spot, in the H spot, or the K spot? It's in the K spot. Now it looks H because it's right next to the X. Actually, you can call it H or K, to be honest with you. But H will typically have parentheses around it. But actually on this one, it's both H and K. That's a little tricky. All right, so I'm going to call it K. And that means that it's going to move up 3 units. It's a vertical translation up 3. So you draw the exact line. It's congruent. You draw the exact same thing, but you move it up 3. number 2. And if you run out of space in your little blue grid, just go outside of it. Draw further. All right, which function family is number 4? This is a quadratic because of the little 2. So use your handout and draw a parabola. It starts at 0, 0, and then it goes over 1, up 1. But in a parabola, our next point is over 2, up 4. And my hope for you is in the next several days that this is something that you have committed to memory. That the parent quadratic, you could just know what it looks like. Go in the origin, over 1, up 1, over 2, up 4. You know, just to be able to draw that one. So now, this equation, light blue, has a -2 in the equation. It's not just a parent function. So do you think that's in the A spot, the H spot, or the K spot? This is an H value, so that's a horizontal translation, which means we're shifting it left and right. And here's where it's tricky. It's going to go to the right 2. That's tricky because our very intelligent, reasonable brains know that a minus usually means left. But H, for lots of reasons, there's actually opposite of how it looks. It's the only one that's opposite. H goes opposite. So even though it's a -2, we're moving it to the right. So it's the exact same parabola. I take every point and I count right 2. And I redraw it. And that's the transformation, a horizontal translation right 2. Just like a figure in geometry, but it's a whole function. And number 5 is our absolute value bars. And I bet you guys, I think you've done it once, maybe twice. I bet you already have it memorized. Well, this group did, right? They came up and drew it. It's a nice little V shape, perfectly symmetrical, centered at the origin. That's the parent. The only thing different here from the parent function is the negative sign in front. Is that negative sign an A, an H, or a K? It's in the A spot, and it's negative, so this is a reflection. We just need to flip it across X. The negative sign flips it. And that's class, you guys. This is what you're supposed to achieve today. You're supposed to see numbers and equations and start to figure out and analyze how those numbers are going to move the function left, right, up, down. Tomorrow we'll be more focused on the skinnier, wider bit. So when you're ready, you have up until the bell. Don't stop early. Work all the way to the bell. You're on the same page as yesterday. Number 7 through 13. Yeah, I think it is the next page. When I said that, I blanked out for a minute. Yeah, we're on page 14. Flip that over. 7 through 13. Who still needs the whole punch? Do it all at once? You sure yes or no? All right, so we'll turn them all out, and then you can go up and hold on. Somebody have their hand up? We're in the last 10 minutes. You said